This is the difference between a chatbot and an agentic system. A normal chatbot retrieves information. An agentic system orchestrates context. That sounds subtle, but it completely changes how AI systems work. Most basic chatbots do something like this. Question in, search one source, return an answer. Usually it's just vector search wrapped around an LLM, but modern agentic retrieval systems are far more dynamic. When you ask one question, the system may break the question into multiple optimized queries, choose different retrieval strategies such as NPCs, tools, APIs, sub-agents, search across multiple systems simultaneously like vector databases, SQL databases, CRM, Notion, internal docs, merge results together, re-rank everything for relevance, and return only the highest signal context. That's why some AI systems feel dramatically smarter than others. It's not necessarily because the model's better, but because the retrieval architecture behind it is far better. The future of AI isn't bigger models. It's systems that can coordinate information across fragmented environments intelligently, because enterprise knowledge doesn't live in one place anymore. It lives across workflows, databases, tools, permissions, and disconnected systems. The chatbot is one interface, but retrieval orchestration is becoming the real intelligent layer. Now let's figure out how the system actually works.
All right, so this diagram you see here describes how the agentic retrieval system works across multiple sources. So we'll go dive deep in, figure out. So we're going to start right here with the user's query. So user's query comes in and we have our first agent. And the job of this agent is to break apart the user's query into two different types of queries. We call them query 1 and query 2. And these are the RAG optimized queries. RAG stands for Retrieval Augmented Generation. And these queries are an optimized version of the original query that's best suited to do retrieval augmented generation. And so we're going to use these two queries to then feed into our retrieval options that we have here in this section here. Now, retrieval options can be several different ways. For instance, Microsoft Foundry has an MPC server that connects into their data sources, and they have multiple different ways to store data. And so you would use their MPC server to access the data. Another way is to just use a retrieval tool to then access your data sources. So this can be something that maybe is inside your CRM or Notion. And so this would be a specific tool call that then accesses that the data storage, wherever that is, and then you get access to the data. Or you can just use another sub agent, and that might be something that you built on the side, and then you would call using the query. So the reason you make these different queries is because you might have different ways to access your data. And so these retrieval options might require different types of optimized queries. And then we go into the next section over here. We're going to be asking our LLM to go in and find the answer for our specific query. I listed here 4 sources, but they can be more than that. It could be 4 sources, it could be 10 sources. But essentially, these might live in these different types of areas that I talked about earlier. What we're going to do is then use these sources to then find the answer. Now, these sources might be separated based on context. Maybe they might be separated based on the type of data they might have. Let's think of an example. For instance, maybe it's a business that might have product information in one data source and company information on another. And maybe the query comes in that asks for specific pricing, but also maybe they're looking for warranty as well. And so maybe that sort of information may not be here, but it lives here. And so when we're doing a query, we might want to search these different data sources. And then once we do that, we're going to get our answers. Pricing can be inside a SQL database, but also it might be on the website's information page as well, right? To get the most accurate answers, the best to source our answers from different knowledge sources. Once we do that, they might have overlapping information, like duplicate information from these different sources, because they might share some of the information. Again, they might be contextualized in a different way. What we're going to do in this stage here, we're going to merge those results into one so that we can then look at them in the next stage where we're going to rank them. And so here, a re-ranking is where we're going to pick the best 3 to 5 results of those. So when we merge them, you can think of it as kind of putting them one above the other, like a list, and say, these are all the results. Let's just say pick a random number right now, 5 results came out of all of our sources. Then there, what we're doing with re-ranking is saying, okay, out of these 5, these 3 or so are the best response for this particular query. And so we're going to re-rank them, pick the best 3 to 5, and then use that to feed into another agent that is going to look at that response and say, okay, this is the question. These are the answers. here's my user response. And the user response may be formatted this particular way based on how that agent is orchestrated to give the response to the user. This is called the agentic retrieval across multiple sources. And I believe this is a much better way to get the response to the user than simply just to kind of do it like a sort of a chat interface, or maybe even just one data source. Here, in way much deeper, we're looking at different data sources, merging the results, re-ranking them, and then we're creating a response.